Hi, this is Bryce,
And I'm Fiora.
and this is
Fire Science.
don't try this at home. Almost anybody, unless you are very comfortable with the chemistry and fire safety.
And you should probably do it with your dad.
If you're a kid, do not attempt this at all. If you are a parent, be very careful and test before you get your kids involved. Today, we are going to be making hydrogen gas balloons and then blowing them up, because that's half the fun. So, I've written what looks like a complicated thing on the board, but this explains exactly what we're doing. So, we are going to be mixing some things together to make hydrogen gas. Hydrogen gas is the lightest element in the universe. It makes up, I'm going to get this number wrong, 97% of the universe. It is what most of the sun is made up of, hydrogen gas. So, what we're going to do is we're going to take aluminum, that's foil, which we wrap our food in. Sodium hydroxide, I know that's a lot of word, but that is just drain cleaner, which we have right here. And water, which is right there. We're going to mix them together to make sodium aluminate, which we don't care about, and hydrogen gas. And we're going to capture it in a balloon. And so some important things, because we're playing with fire and we are playing with hot stuff and dangerous things.
He has his fire safety glove, and we're wearing these safety gloves.
That's right. And we're wearing long sleeves because this sodium hydroxide is also called lye, which if you're making soap at home, this is one of the main ingredients you use to make soap. But it's caustic, which means it can hurt our skin. And so we're going to cover up and make sure we try not to get anything on our hands. Actually,
Yeah.
Jenny, could you go grab us some vinegar?
Yeah.
It is what we will use in case we get any lye on our skin. We'll pour vinegar on there right after. And I'm sure all of you recognize this. Fiora, what is this?
Fire extinguisher,
That's right. What's it used for?
blowing out fires.
That's right. And so we have this here in case we start a fire that we can't control. We get the fire extinguisher and put it out, but we should be okay. We're going to make our solution right here, because this is a sodium hydroxide plus the water is going to make ions plus water. But you know what this E is?
No.
Here, step out of the way. This E is energy in the form of heat. So it's going to get hot. So the first thing we're going to do, I probably shouldn't roll up my sleeve, is we're going to put, so when making soap, they always tell you to add the water first and then the lye crystals. Do you know why, Fiora?
Why?
Why do you think? Because we don't want to get this on our skin, so what would be the reason to add the water first?
Because I don't know.
Well, think about when we, like I just did there, the water sprays everywhere because it's a liquid. And so we don't want this to splatter. So if we put the crystals in and then add the water could spray out the crystals and get on our skin and it could hurt. It won't kill us, but it would be unpleasant. So I want you to come spray some water in the bottle.
How much about?
Probably about to here, yeah. Because this is going to steam, this is going to make heat, do all kinds of things. And so we want to be careful. So the next thing we're going to do is we're going to add the lye crystals. I'm going to handle the lye crystals, but I want you, I'm going to just take some in this funnel.
Can I hold the funnel? You just do it.
Now just hold on to it, it'll be fine. So Fiora, I want you to come, we're going to mix it up a little bit. I want you to come feel the side right here and tell me what you feel. Is that warm?
I like it.
Yeah. So this is the heat that is coming out of this equation right here. So the next thing we're going to do is we already have this part of our equation, sodium hydroxide plus water. We're going to be adding aluminum, and we're going to start a little bit of the reaction. As soon as we put that aluminum in there, it's going to start dissolving, turning into little crystals of sodium aluminate, and going to release hydrogen gas. So we're not going to capture any yet. We're just going to do a little bit to show you what it looks like. So Fiora, what I want you to do, I want you to take this and just drop it in the bottle. Oh, it's okay. Now what? You see it?
Bubbling.
Yeah, it's bubbling. Step out of the way. Over here. Come over here.
Mm-hmm.
Yeah, come to the back. That's fine. So yeah, you see. What do you see? What's going on?
It's really bubbly.
That's right. You see what's going on there?
Yeah.
Yeah. And so what's
Let's
coming
get
out of
close
this?
to show
Oh yeah, that's true. Actually, let me come up to the. Let me get one more piece of foil, and I'll get up close so you can see it. And then we'll put in a bunch of foil, create a big reaction,
And we'll go.
and fill a balloon with hydrogen.
And probably go.
Oh, good.
Yeah.
Yeah.
You can hear it.
So yeah, so all those bubbles, that's hydrogen gas. Hey, get off the ladder, please. That's hydrogen gas that's coming out of the reaction. And if you see the water, do you see the water's getting a little bit cloudy, like and dark?
Yeah.
That's little bits of sodium aluminate, what's left over. So sodium aluminate stays in the water, hydrogen gas billows out. All right, so next thing we're gonna do is we're gonna put in a bunch of foil and we're gonna capture it with a balloon.
So Dad, I'll get.
So you wanna grab a balloon?
I
Color of
want
your choice?
I'm gonna do red.
That sounds good to me.
Red like fire.
Yeah.
Next we should do yellow. We do
So
another
yeah, we can probably do a couple. So the first thing we're gonna do is I'm actually gonna blow this balloon up once because I wanna stretch out the rubber so it's easier for the gas to enter. And so, I just filled this with air from my lungs. We've all blown up balloons before. What happens if I would let go of this? Well, if I tied this balloon off and let go, would it go up or down? That's right. Because it's just air. It's just like the air that's in the air. And the balloon is heavier than air, so the whole thing would fall. But do you remember what I said about hydrogen gas? What does hydrogen gas do? It goes up. That's right. Can I come in the frame? Make sure you're in there. See? So yeah, so when we fill this with hydrogen gas, what do you think it's going to do? That's right, it's going to go up. But what do we normally put in balloons? Do you remember? Step back a little. And people can see.
It makes you talk like this.
It does make you talk high and funny. That's helium. That's actually the second most common element that's everywhere, and is also lighter than air. So we fill our balloons with it. But the reason we don't use hydrogen to fill our balloons will become very evident by the end of this. Here's what we're going to do. I'm going to do this very quickly. I'm going to take this foil, put it in there, and then I'm going to put the balloon over to trap the hydrogen gas. So do you want to put the foil in? All right, get on the other side. Actually, you can do it right here. That's fine.
3, 2, 1. It's turning gray.
Yeah, and look at our balloon.
At the end, are we gonna let go?
Nope. We're going to show you why we use helium instead of hydrogen for balloons.
I'm a flyer. You should bring it up close.
Oh,
What
sure.
if you fall off?
Oh, no, oh, yeah, it's very hot. Good. As you can see, our water is getting very dark, filling up with sodium aluminate. The bottle's getting quite hot. And the balloon is getting fuller. I think this is about as full as we can get the balloon. That's okay. And so as you can see, there's actually some gas coming out the top. Fee, can you see that?
Yes.
Most of that is actually steam that is coming out of there.
It is.
So what do you think has happened now that it's not bubbling anymore?
It's just a bunch of goop and stuff.
Yeah, what do you think has happened?
I think since this is gray, some of the color went into it.
Could be. So the wind is not doing us any favors right now. But as you can see, if I hold the balloon like this, where's it going? That's right, it's going up. So now, the problem is the string is a little bit heavy and it's very windy out here. Yeah, so let me see if I can get this to be a little bit tighter. This last part we're going to do together, and is the part that is mildly dangerous and why we don't make hydrogen balloons normally. So what we have here
Our matches.
Matches on the end of a pole where we normally have a broom.
I'll get the broom.
We don't need the broom.
I just want to show them that it actually is broom. See, it was actually a broom. We just pulled it off. Is that right?
So as much as I would like to do this inside, where there is no wind, we are going to create an explosion because hydrogen gas is explosive.
Oh, you throw it over there.
Nope, we're going to pop it right here. And it's going to make a pop boom. All right, so come on over here. Here's what you're going to do, Fee. You're going to hold on to this. I'm going to light the match, light the end here. You're just going to take this and you're going to poke the balloon, okay?
Okay. I'm scared.
Don't, you know?
And then what will I do?
And that's it.
Okay.
Just don't freak out. Yeah, one down. We'll try again. Also, problems with the wind. All right, take it and poke the balloon.
That smells good.
So,
You guys see the smoke?
yeah. What happened when you poked the balloon, Fee?
It made like an explosion.
That's right. Because hydrogen gas, and you know what's really cool though? What do you think is made when we blow up the hydrogen gas? So, the hydrogen gas only explodes when it's around oxygen. Where do you think the oxygen comes from?
The trees?
Well, yeah, from the trees. But also, it's just in the air, right? So we breathe it in all the time.
It also comes from trees. So we give the trees stuff and the trees give us stuff.
Yes, we give the trees.
No trees we don't really give.
We give the trees carbon dioxide, which actually it's what's in the fire extinguisher. Fire extinguisher will put out fires. But yes, there's oxygen in the air. There's hydrogen inside the balloon. When we add fire, fire makes a reaction, and we actually get. Here, I'm going to write something on the board, and then I'm going to ask you a question about it. This is hydrogen gas, like we talked about, that we got out of the bottle. This is oxygen. Step out of the way. Step over here. This is oxygen that's in the air. We're going to add a little bit of heat to start the reaction, and then we get this. What is this? Do you recognize this?
Hydrogen oxygen?
Hydrogen oxygen, but look on the board. We have it also here. We have H2O. It's the same thing. What is that? What does that say? That's right. So what do you think this is?
Water?
That's right. So we take hydrogen and oxygen, we light it on fire, and we get water. And it's actually a really clean reaction. But because there's oxygen everywhere, we can't escape it. If we made hydrogen balloons, they would be blowing up all the time. You want to do one more? All right.
We're gonna get a lot for this one.
Yeah.
Because that's giant.
Yeah, and so you see how it's actually getting out more gas because I opened it up more? Yeah. But see, watch the foil. Actually, let me see if I can get this up close to the camera so you can see the foil.
Yeah, it's getting all bubbly.
That's right, and look at the bottom of it. You can see the bottom.
Wow.
That's crazy, right?
Yeah.
So part of what's happening is on the edges of the foil, there's aluminum oxide. And aluminum oxide actually,
So what's this?
I don't know. Oh, that is getting quite hot, so I'm going to go and take it off. Whew.
I think it just foam.
All right, so I'm going to get my heat glove.
I think that's enough.
Yep. So do not, Fiora. Never sniff anything coming out of a chemistry bottle. You'll live. But a lot of that coming out of that is water vapor because it's boiling. This is just like it's getting hot enough to boil. And so, but there's also lye in there, which we talked about as caustic. and can cause damage. So, yes. Important thing in chemistry, don't touch or smell anything unless you're told to. You'll live.
It's good.
It's good. Yeah, actually, if you look at our last string. It blew off the end of it. Our balloons actually get pretty small pretty quickly. That's because hydrogen is so small. It is the smallest element in the universe. It can fit through tiny spaces.
Dad, this time can you?
You want to watch?
Yes.
And I'll do it. Sounds
Can you
good.
open my eyes so I can see it forward?
That's right. Sounds good to me.
I'm gonna sit back.
Yeah. So the other reason we don't use hydrogen balloons, besides the explosions, which if you want to look up some fun about hydrogen and why we don't use it a ton, look up the Hindenburg. It was a blimp, which is a giant balloon that people would fly around in, that had hydrogen in it, and it lit on fire. And it crashed, and people died. So we don't do that anymore. Which is kind of sad because hydrogen can be used safely. You just have to be careful. Ready for the next boom?
Yes, I'm gonna open my eyes. I want to see the whole thing. I might go. I'm excited.
Very good.
I'm standing back.
All right, 3, 2, 1.
Oh, that's so loud.
Yeah.
Yeah, is that the end of the lesson yet?
Do you have any questions about anything?
Well, okay. Where's the matchbox? What is this?
Oh, actually, that's an excellent question. Let's talk about how matches work. This won't even take very long. So, if you look on the end, do you see two different colors?
Yeah.
There's white and there's red. I don't actually remember what the actual chemicals are in here. Let me get up close to the camera. What happens when we rub it on the side of the box, you want to feel the side of the box with your finger? Is it rough?
A little bit.
Yeah. So, when we rub this against the side of the box, there's friction, which is heat, and it mixes these two chemicals together and they make a fire, just like our hydrogen and oxygen reaction.
Okay.
So actually, we're going to do it right up here.
Dad, can you just show us what that does? No, it's supposed
No. Maybe some other time. So yeah, as I'm rubbing it together, you can see that's getting all kind of worn out.
Yeah.
But we're going to do it fast enough to get the reaction to start.
And it starts a fire.
And it starts fire. Mind you, it's very windy out, so our matches go out very quickly. All right, that's all for now.
This is good. Goodbye.
You should talk to the camera.
Hello.
And this was Fire Science episode 1. We'll follow up with more soon.
Goodbye, friends. Goodbye.
All right, poke the balloon. Nice job, buddy. Was that so cool?
Yeah.
Yeah.
I'm a face.
Yeah, actually, you probably do get splattered with water a little bit.